Okay, so let's do a calculation using standard enthalpy of formation. And what I did is I went to Appendix G in your book to find the standard thermodynamic properties listed there. And here's the question. What is the standard enthalpy of combustion for 1-propanol? And so I gave you the formula. And so combustion reaction is C3H8O plus O2 yields CO2 plus H2O. So I need a 3 here, and I need a 4 here, and that gives me 6 plus 4, which is 10, so it would be 5 there. So there's my balanced chemical equation. And what I'm going to do to get this standard enthalpy of combustion is going to be the sum of the products, which is the number of moles of CO2 plus the number of moles of H2O minus the sum of the number of moles of O2 plus the number of moles of C3H8O. So, starting here, I'm going to start with CO2, which is here, and that number is negative 393.51, and that's kilojoules per mole. And that's going to be multiplied by this coefficient, which is 3 moles. And I'm going to add to that, N for water is 4 moles times the number for water is negative 283.83 kilojoules per mole. And I'm going to add those two numbers together, and then I'm going to subtract from that the numbers for the products, which is going to be 5 moles times the number for oxygen in any element in its standard state is going to be 0, and that's kilojoules per mole, plus we have 1 mole, and we always have to have a 1 here, it can't be 2. And the value from that I had to look up on the internet, which is negative 255.22 kilojoules per mole. So, getting out my calculator, I'm going to take, you can't really see that, so let me slide it up a little bit. Still can't see it. So, you'll just have to trust me. 3 times negative 393.51 plus 4 times negative 283.83 equals, and I'm just going to add up my products, and so that's going to equal negative 2311.85, and that's going to be kilojoules, minus, this term is 0, so minus a negative 255.22 kilojoules, because the moles will cancel, and so that's going to equal, so to this number I'm going to add 255.22 equals, and I get the enthalpy of combustion for 1 mole of propanol is negative 2056.63 kilojoules. The number of moles is infinitely significant. I have 2 decimal places, 2 decimal places, and 2 decimal places.